Alright, let's see. Okay. First, where's this? Probably Africa, yeah. Namibia. Okay. So back to this. Right, so we need to debug why does this not see all of this? So why does the number not 1, 2, 3, 4, right? Because technically you can see this guy, right? Or because this guy was eclipsed by the max guy here, right? So let's run through our stuff right here. So you want somehow when 10 oh, if we do the reverse of this, what happened? Because we only want 10 to see 6, 8 and 11, right? So that means we don't want 5 to be in here. So 5 should be eclipsed by 8, right? So it looks like the reverse order of this should work, right? So let's say you starting with 9, right? So this is 9, 5, right? The stack is empty, put it here, and you're looking at 4, right? So 11 is greater than 9, right? So you push 11 on the stack, and that's one, right? So you look at 5. 5 is less than 11, right? So then 5 will put on the stack, right? Right? And now 5 compared to 8. Because 8 is greater than, right? Then 8 would kill 5. Right? We have 6. 6 is less than 8, so 6 is going up, right? So 8 is 2, sorry, 1. Eleven, 4, right? And now we see 1, right? 0, right? So basically 10 gonna kill 2 plus 1. Okay. gonna be 0, 11, 4, right? So this should work. So in this case we don't see 5 at all for 10, right? Yeah, let's do that. So this one basically so 11 greater than, right? So this logic is still the same, but we loop in the back, right? So I equal length of times minus 1, right? So yi is greater than or equal to 0, right? Minus 1. Okay, so this is greater than, right? So first the stack is empty, and we do 9 of 5, right? So now if I go up here, and then 11 gonna go and kill it. Right, so gonna be this should be stack minus I, right? Okay, so the result of this will be, I'll just do this. Okay, 5 we put on this, so now 8, right? 8 is put on the stack, yeah. So 6 put on the stack, right? 10 gonna kill 6 and 8, so that's gonna be 1, and 8 is 2, yeah. 2, right? Maybe this will work already. Oh. H of the height. Wrong. Okay, so what's wrong here? So this will be 1, right? So the number of 10 gonna kill is the number of this guy plus 1, right? So 8 gonna be 2. Okay, so basically the number here So the result of, okay, so let's check this. The result of the, what's h here? The result of I is actually gonna be plus equal to 1, right? Which is the number of time it killed this thing, right? So 9 here. So okay, good. If you start with 0, good. And what's it? 5 go here, good. So 8 can kill 1. That means 8 gonna plus 1 already, right? And 6 go in here, right? So 10. So with this, do we starting with, okay, so what does this print already first? So put 5, okay. This one, good, right? Five here. So 8 wanna see 2, right? So okay, so this gonna be result gotta be plus 1, right? If we get into the loop at all, right? In loop, basically can see false. If it even go into the loop, you can see. Okay, right. So if we did go into the loop, I'm gonna have to do result I just go on, because we have to account for the last one, right? Because we did not see the last one. Okay, so let's take a look. So we killed this guy, so it's gonna be plus 1. Right, so yeah, so he's not okay. This guy killed this guy, so that's gonna be plus 2 because you can see this. And this guy go up, and this guy can kill 2 guy, 1, 2, right? It's gonna be 3, right? So what's the outcome here? What? Why is it not 3? Wait. Okay, so this is 0. Eleven is 2 already, good. 11 can see 1. Wait, hold on. do this. Yeah, 11 can see 1. H stack and resolve. Okay. 3 is 8. So 3 is on the stack. Yeah, 3, 4, good. And 8 gonna kill 3. 8 gonna kill 6. So this gonna be 1 right here. And then 6 is here. So it's gonna go up, good. And now 10. 10 gonna go and kill everyone. So right. So we go outside of this. All of this guy has to account for this, right? Except the last guy, right? So it's gonna be 4i in range of stack, right? This is result of I plus equal length of stack minus, we have position i's, gonna be the length minus this, right? Minus I, right? Okay, let's see. 4. We miscount somehow. Hold on, let me see who is sending me a message. Promotion. Yep. Transaction. Okay. Let me check what did we do wrong. So this is greater than this because we can kill this guy. The result of this is gonna be plus 1 of these. Is it true? Right, and then we see 8. 8 can kill 5. So it can kill these, right? But it cannot kill this guy, right? So that's gonna be plus 1, right? but we got 1, so we miscount 1, right? So basically we can kick out this, right? This is gonna be if we kick out this, that's gonna be 1, right? But in this case we have to plus 1, right? Because we can kill this guy, that means we can see this guy, but we cannot kill this guy, but that also means we can also see this guy, right? So we see this guy for sure. So if so if that, right, then result I is equal 1. Okay, so if length of the stack is greater than or equal to 1, right? Greater than 1, right? Because if it is 1, we already count them, right? If it's greater than 1, that means we miscount. We kill one guy, but we miscount this guy, right? Could that be it? And 6 is up here, 10 here is 10 kill 1 2, right? And because so maybe we don't, because after that the stack is greater than, that means that we have to do plus 1, right? So does that mean we don't have to do this? Let's see. Okay, what do we have? Wait, when we got to 10, what happened? 2. Wait. We got 2, right? And oh, okay. We have to move this to here, right? Yeah, there we go. Let's go. Let's see. Come on, something wrong then. Speeding up. Time limit exceeded. Wow, bruh. Maybe the inefficiency is this, or we have to keep, right? So we put them on the stack here. We have to come back too much, right? Hmm. We have some limit exceeded here. I think it's because of this part right here. I don't know why we infinite loop here. With these big cases, we somehow so this is the case where the height is sorted, right? So that means every time, so we look from the back, right? We take this, put them on stack, and new number keep less than, right? So this problem is we ended up keep adding people on the stack, right? Right, so yeah, so if length greater than 1, result I, so that's equal 1. So that means this person can see this person. What? Something wrong here. Okay, so if we do it this way, okay, so we put, okay, let me write them down. until we put empty and put 1000 on. And next thing we do, we put this 10,000, 100,000, and this new number we keep putting them, right? 99, whatever this is, right? So we end up putting all of them to the stack, right? Right? Because this thing always greater than, right? So this means this is sorted. What? It passed here. Can we just resubmit and somehow it passed? It's 8,000 though. That's bad. Right? Oh, someone trying to call me. Who is this number? Private name. What? We call them. Let's see. Yes, this is a scam. Okay, so this run separate is working here. But it doesn't work on when it's run the total suite. don't know where did we go wrong here, but let me think for a moment. So the top of the stack in the case that this is sorted, maybe the problem is we do too much pop. If we can cut down the 8,000 here, that would be great. This new number keeps being greater, right? So this become ON square here, right? If the array is sorted, right? Because we put them on a new one greater than no, we put 100,000 in. Hold on, let me check the stock real quick. Ooh, stuff doing bad. Let me check real quick, guys. This is my stuff. Okay, so the problem with this okay, for every element, if the height is greater than the top. Okay, so now we have 100,000. It's the first thing, and then we have to look at 99,999, right? So is it greater than? No. It is not. Then you put it on stack. Right. So we keep putting all this, and we say if the length is greater than 1, then we increment by 1. Right. So the last guy is gonna be 0. Right. But this cost of runtime very high. So we do equal, because technically what did we do wrong here? I mean, it works, still time limit exceeded. Something wrong with it here that we need to optimize. This will be all 110, right? Maybe we could try hack and see if the thing is sorted, then it's just gonna be, but that was only for one case, no? Right? So let me get some water. Or maybe instead of right, because the problem with this is probably, my guess is array shifting, because Python has a queue. DQ, because we 101 of the stuff, right? Okay, how do you do DQ? Append, pop left. Let's try that. Does LeetCode support DQ? Let's call this DQ. Right? Is that how you use it? DQ, and you pop left. How do you check the top element? Python DQ pick left. What? Oh, you can do index, okay. Then you basically pop left now. Try that and see if it improve. DQ is not defined. What? So LeetCode does not support DQ. Wait. DQ. Oh, D key. Let's try that. Can only concatenate. Where? How do you push on the front? D key. How do you push? Append left. Append left. This element. Oh. Oh. Try that. Okay, so that's the issue, guys. So list is very slow on the case of hopping front because it has to reshift the element, I guess. In the case of sorted list, sorted input would be very slow. So use Python DQ, right? Let's submit this and see. There we go. Amazing. Okay. Oh my god, what is this? Okay, at least we finished. Week 1. Right. So we'll have to do week 2 later. Right. But it was nice. There we go. I'm okay with this not being optimized, not being like beating other people. Okay. So I need to look more into DQ. Right? DQ. That seems to. It's a good problem. DQ. For now, deck, double-ended Q. Okay. So now we're gonna do is we're gonna go in programming and see if there's an article to read in React. Or maybe let's wrap up this, right? Go back to this because yesterday we didn't finish it. Right? This one. Right. So this one gave the wrong result, right? Division by 0, whatever this is. Right. So let me see. So we have a duplicate, right? We want to distribute them, right? So in this case, for example, we have 2 is 2. Right, and 3 is 1, and 5 is 1. So basically k equals 2. So that means we need 2 elements, right? We look at the top 2 and we say, oh, we can decrease them. If any of them become m becomes 0, you remove them from the dictionary, right? And we decrease this by 1, and we continue the same process, right? That looks like we could do a max heap now, right? So we want a pair, maybe the easiest, which is B, 2, 2, 3, 5, right? And then we have a 2 pointer on the front, and we match them, right? But how do we match them with k equals 3 here, right? So let's say 1, 2, 3, 5, right? So k equals 3 means we take these, and but what about duplicate, right? So let's say we have 2, 2, 5, 5, right? K equals 2. This should work, but if k equals 3, right? So 2, 2, 3, 5, 5, 5, let's say. And if we do a 2 pointer, right, which is fail, right, we want to have a way, basically we do round robin across different key, right? So we have 2 and 3, right? 5, wait, hold on, 6, 6, 6, right? So we have 2, 3, 5, 3, 6, 3, right? So we just look through, this is what this approach is. But it's a lot of like minute like logic here that we need to simplify. So say we have 74 is 2, 103 is 1. Right, we would have ideally we want it to always sorted, right? But that will be very expensive. What is the topic here? Half table and counting, I know. Right. Seems simple, but it's not. So k here equal 3. right? So the first thing we need to check it, if the lesser key is greater than 3, then it's good, right? For this case here, we got 81, 90, 35, 38, 98, 108, 87, 108 again, 2, 92, 36, 108 again, 96. Okay, hold on, let's comment on R first. Okay, 3 here is this one true. So 3, 3. Yeah. So we would do 108 with any 92, good, and then 26, 96, and then 38, 98, then we end up with 3, right? We sort them, so we wanna pick the max number first, right? So because we want the end result is the big one die first, right? Right, so 108 here, just pick any of these numbers, and because we picked the number, right? It will be slowly decreasing. Okay. To the point where, so like, let's say 3, 3, 2, 2, 1, 1, 1, 1, 1, right? So we pick this number, we pick 3, we pick 2, so this becomes 2, 2, 1, right? But it's not 2 here, right? So do we keep sorting though? That's the main problem. Right. Or like instead of sorting, right, we just go around, right? Does the strategy work? Right, so we is 2 right, so we have 108, 108, 108. Do we just simulate the problem, or is there a way to say because basically you want to distribute, right? So in this case there's 4 elements, right? And there's 2. There's so we have number of group here is each group is 2, right? And somehow after the other problem my brain fries. Maybe we'll have to come back to this. Let's do that. And let's look at the stuff here. And because I probably go eat in 30 minutes. That's crazy. What? Okay, where's the... They are because of AI? Why did you say sorry though? Like take a pay cut or something. Okay. Why do they say sorry? Take a pay cut or something? Or just do not hire like this in the first place? Why does the CEO not take pay cut? Like Nintendo, right? Nintendo CEO take pay cut, right? Yeah, this one, right? But they don't do that in America, right? They don't do that in America. Right. Reddit. Yeah, it's not like Jira is. Not like Jira is like cool, I think. Jira actually bad. So it seems like it's a combination of not profitable and overhiring. So just don't hire like crazy then. Atlassian struck. Oh my god. Look. Nice. This is referring to the book Atlas Shrugged, right? Very nice. I need to take some water. Hiccup. Bye-bye, server. All right. What else can we see? Yeah, in Turbo Tree. This. Let's see this. AWS. Wait. This is an old article, right? Should we want to take a look though? Let's look at the latest article then. What? Yeah, whatever. Look at the news. Willingness to look stupid. Take a look at this. I think this is similar to what is it? What is it? News.ycombinator.com. Oh yeah. Nobel Prize winner stopped doing great work. An early recognition ruined your the expectation and pressure you next big things are immense. New bar is higher. New idea. Young. article because they have good expectation and they want to look stupid. We started with a bunch of good ones will follow. Overshare, undershare. Creative process started with creating yourself and not needed to fit any audience. Right? Are you willing to look stupid? Yeah. Yeah, very good article. It's a cool block. Alright, I think I'm gonna go eat now and play games, and probably come back to this in a little bit. Trying to solve that problem and write the substack for the day portion, ease. And then I have to hold hands with my friend. And that's it. Thank you. Be back in a while.